We go to the lesson 4 of finding limits. You should read the PDF. You should read the definition of what it means to approach. When x approach to a point C, what's the value of the function? It approach to a fixed number. If it approach to a fixed number, we say that this is the limit. But you never touch the point. The point C, you will never touch. You will approach C as much as you can. These are the formulas for limits. We see everything during the class. And let's go to do this is example that we have seen during the class. We have seen this example also during the class. We have discussed this limit. We have discussed also this limit. And now let's go to the example. The first example here is to find the limits of x squared minus 9 divided by x minus 3. Let's go to do it when x approach 3. Okay, so this is the limit that we want to calculate. When x approach 3, x is never 3. X approach 3. X approach the number 3. So means that here there is a function. The function f of x. Function f of x is x squared minus 9 divided by x minus 3. When x is 3, the function is not defined. But when x approach 3, let's say 3.0001, the function is defined and have a value. When x approach 3 from the left side, the function, the x is 2.99991, the function have a value. Well, when x approach 3, to what approach f? That's the question. So there are 3 ways to visualize the limit. The first way is the graphic way to visualize the limit. The second way is to use numbers like x equals 0.001. So if you put f of 3.0001 and you say 3.00001 squared minus 9 divided by 3.00001 minus 3, to where it will approach. When x approach, when x approach 3, so it will be 3.001 or 2.99991, depending if you are approaching the 3 from the left or from the right. The question is, what will be the value? What will be the value? It will be a fixed value of f of x. What will be the to what it will tend the value? If you see that it will tend to a fixed value, if you find the limit when x approach 3. Now let's go to the next to the 3, and you make the same calculation. 3.00001 squared minus 9 divided by 3.001 minus 3. If you do this, you will approach to the number 6. So the second way is data. The first way is to use a graphing utility, and the third way, that is the correct way, is to do the algebra. So the limit. Let's go to do the algebra. The limit when x tends to 3 of x squared minus 9 divided by x minus 3, this is equal to. Now, a squared minus b squared is a minus b multiplied by a plus b. This means that x squared minus 9 is x minus 3 multiplied by x plus 3 divided by x minus 3. I might have to do the limit when x tends to 3. Now this x minus 3 cancel, and we have the limit when x tends to 3 of x plus 3. When x tends to 3, the value of the x will be the 3, so the limit will be the 6, and this is the limit. So now, what it means, what we have done. The function x squared minus 9 divided by x minus 3 is equal to x plus 3, because x squared minus 9 is equal to x plus 3 multiplied by x minus 3. So the function x squared minus 9 divided by x minus 3 is x plus 3 for all x except at x equal 3. At x equal 3 is not equal because it's not defined. So the graphing utility will say that if you represent x squared minus 9 divided by x minus 3, the rectilinear line x plus 3 is a rectilinear line that when x equals 0 is 3, when y equals 0, so I'm representing the line y equal x plus 3, when y equals 0, x equal minus 3, so is this line, this rectilinear line. What it means this? It means that the line x plus 3 is exactly the same function that x squared minus 9 divided by x minus 3, except at the point 3. At the point 3, there is a hole. So the function x plus 3 is the whole rectilinear line. And the function x squared minus 9 divided by x minus 3 is the same rectilinear line with a hole. With a hole is not defined at this point. Okay, it's not defined at x equal 3. So the limit, when I approach to the 3, the limit will be 6, will be x plus 3, will be 6. When I approach to the 3, to x equal 3, when I approach to x equal 3, the value of the function will be x plus 3. X plus 3 is 3 plus 3. If I approach 3, it will be 6. I hope it's clear. Now let's go to do this limit, the limit. When x approach pi, it's never pi, it's approaching pi, of the function sine of 2x. When x approach pi, sine of 2 pi is 0. So it approached to 0. So the limit will approach to 0 because when x approach to pi, sine of 2x approach to 0. That's the limit. Now let's go problem number 3. It says find the limit when x approach 4 of the cubic root of x plus 4. When x approach 4, x takes a number, a value of something very, very next to 4. Let's say 4.000000000000001. So this limit at what it approach? It pure approach to the cubic root of 4 plus 4. It approached to the cubic root of 8, and this is the result. And what is the cubic root of 8? Is 2 by 2 by 2 is 8, is 2. So this is the limit. Now let's go to do problem number 4 that say find the limit of x squared plus x minus 6 divided by x plus 3 when x approach the number minus 3. At x equal minus 3, this function, the function f of x, is not defined. Because when x is equal minus 3, in the denominator we will have a 0, and division by 0 is not allowed. So the function doesn't exist at x equal 3. What we are asking with the limit is, when you are approaching the point x equal minus 3, to what fixed value the function will approach? To do this, we can do it in 3 ways. The first way, use a graphic utility represent this function. Second way, make the data, plugging numbers, plugging x equal minus 3.00001 or x equal minus 2.999999 and see the value of the function to which it will tend. So the second way is the data, and the way to do it, the algebraical way to do it, is to do the limit. And to do the limits means that you have some manipulation to do, and if you find the root of x squared plus x minus 6, you will see clearly that this can be factored in x plus 3 multiplied by x minus 2 divided by x plus 3. And now I can cancel x plus 3 with x plus 3, and this is x minus 2. So the question is, what is the limit when x tends to minus 3 of x minus 2? When x approach minus 3, this will take the value minus 3. Minus 2 will be minus 5. What it means this? It means that the function f of x and the function x minus 2, the function y equal x minus 2, is a rectilinear line that is, when x equals 0 is minus 2, when y equals 0 is 2, is this rectilinear line. So what it say, that when you are in minus 1, minus 2, and minus 3, what it say exactly, that this function, this one is this rectilinear line, because the division is x minus 2, except at x equal minus 3, that is not defined. So at x equal minus 3, you need to put a hole here. So this is the function f of x equal x squared plus x minus 6 divided by x plus 3. Is the rectilinear line x minus 2 with the hole. Wow. Now, let's go to solve this problem. It's the limit when x tends to 0 of tangent of x divided by x. Now, when x is 0, the function f of x is not even defined. F of x equal tangent of x divided by x is not defined. What we are looking is, what is the limit when x approach to 0? So it means that it's 0.001. So it means that the first things that we can do is to do tangent of 0.001 divided by 0.001. Later on, we do tangent of 0.00001 divide by 0.0001. If you do in your calculators and you do against with approaching more to the 0, you will see that this is 1. This is 1. So the data will say that as you approach to 0, the value of the limits will be 1. If you represent the graphic, you will see that it will look like 1. But this is not the way of doing this limit. The way of doing this limit is the algebraical way. This is only to visualize. So the limit when x tends to 0 of tangent of x divided by x is the same as the limit when x tends to 0 of sine of x divided by cosine of x, which is tangent of x, and I will put the x here. Now, when x tends to 0, this is a famous limit. This is the limit when x tends to 0 of sine of x divided by x multiplied by the limit when x tends to 0 of 1 divided by cosine of x, 1 here. And the limit when x tends to 0 of sine of x divided by x, this is 1. And the limit when x tends to 0 of 1 divided by cosine of x, when x tends to 0, cosine of 0 tends to 1, so this is 1. So the limit is 1. Now, see the things. What it means that the limit when x tends to 0 of sine of x divided by x tends to 1. What it means? It means that sine of x is very similar to x when x is similar to around the 0. So sine of x is a function like this. 1 is this function sine of x. And the graph of dx, the y equal x, is this function. Let me do it in another color, is this function, y equal x. So it means, let me do it better. This is the function y equal x. So at x equals 0 is tangent to the line sine of x. It's tangent to the line with the graph of y equal x will look around the 0, around here. It will look sine of x very similar to x if x is very, very small, less than 1. Less than 1 radian means 0.001, okay? So this is the limit. Now let's go to do another limit. This limit is the limit when x tends to 4, approach 4, of this function, x plus the square root of x plus 5 minus 3 divided by x minus 4. Well, when x is equal 4, the function is not defined. What we want to know is when x approaches to 4, the function will approach to a fixed number or will not approach to a fixed number. To do this kind of limit in an algebraical way, you can do the data way of visualizing the limits. You can do the graph, but the algebraical way to do it, you need to always that it appear limits like this. You do the following thing. You multiply by the conjugate. The conjugate of the numerator in this case is a square root of x plus 3 plus 3. And you divide by the same thing, a square root of x plus 3 plus 3. So you have the function x minus 4, and you multiply by 1. This is 1 because it's something divided by the same thing. So it's 1. When you do this limit and you make the multiplication, let's go to do it, you will find the limit when x tends to 4 of what? A square root of x plus 5, here is a 5, sorry, let me correct, you multiply by the conjugate, x plus 5. A square root of x plus 5 multiplied by square root of x plus 5 is x plus 5. Now it will appear plus 3 times 3 times 3 by a square root and minus 3 times the square root of x plus 5. This will cancel and finally will appear minus 9, 3 by 3, minus 9, divided by x minus 4 that multiply a square root of x plus 5 plus 3. So it will be equal to the limit when x tends to 4 of what? X plus 5 minus 9 is x minus 4 divided by x minus 4 multiplied by a square root of x plus 5 plus 3. Now it will be a cancellation here, x minus 4 divided by x minus 4, and this will be the limit when x approach 4 of 1 divided by the square root of x plus 5 plus 3. And when x approach 4, this approach to 1 divided by a square root of 9 plus 3. Or 1 divided by 3 plus 3. Or 1 divided by 6. So this is the limit, 1/6. For sure, you can plug in here an x in the function. You can plug in an x in the function, for example, 4.001. Use your calculator for 4.001. This expression will go very next to 1/6. You can check it. Now let's go to do this problem. If I see the numerator is x plus 4, is a rectilinear line. So it's the rectilinear lines y equal x plus 4. It makes a 0 in x equal minus 4, and in x equals 0 is 4. So this is the rectilinear line y equal x plus 4. And I have to divide the numerator between the denominator that is x plus 4. So the absolute value of x is the v, is this function. You know that, we already saw the absolute value is this function. And the absolute value plus 4 is when you move the graph 4 units to the left. So it will be this graph. It will be this graph. So what happened here? When I divided the numerator is the rectilinear line. When I divide the numerator, you see, this is to the left of minus 4. When I divide this function to the left of minus 4, between this function, it will be minus 1. When I divide to the right of this function divided by this function, it will be 1. It's the same function, you see? They are parallel. So the graph will be like this. The graph of this function, if you represent this is minus 4, when, let's go to do it here, the graph, the graph will be, when x is minus 4, to the left will be minus 1. And to the right will be plus 1. This is the function f of x equal f of x equal x plus 4 divided by the absolute value of x plus 4 is 1 to the right of 4 and 1 to the right of 4 and minus 1 to the right of, to the left of 4. Minus 1 plus 1. So it has limit or have no limit. If I approach from the right, if I approach minus 4 to the right, the value will be 1. If I approach from the left, the value will be minus 1. It will go to a fixed number? No. So it has no limit. That's the answer, have no limit. X equal 2, sorry, no minus. Now let's go to discuss the existence of the limits when x tends to 2 of the function 3 divided by x minus 2. So we said that there are 3 ways of doing. The first way of doing this is to graph the function. The function is not defined at x equal 2. If you have the function f of x equal 3 divided by x minus 2, it's clear that when x is 2, you cannot divide by 0, so the function is not even defined. The question here is like this. When you are approaching the 2 from the right or from the left, are you approaching to a fixed limit, to a fixed number? So the first way I said was to graph the function. So if you have the function, if you graph the function, should do something like this. And you see when you are approaching the 2 from the left, you go always farther and farther and farther. You never arrive to any points because you go to the infinity. You can plug in the numbers and you can see that you go when x approach to 2, let's say x equal 2.00001, you are approaching to a big number. And if you take x equal 2.000000001, you are approaching to even a bigger number. You never approach to a fixed number. So your intuition will say that there is no limits. But with this function especially, there are 2 things. If you are approaching from the left, the function will approach to a negative number. It will do like this. And as you approach to 2 minus means 2 from the left, you will go to the minus infinity. So it will not arrive to any fixed number, never. Infinity is not a number, infinity is a concept. And for sure, infinity is not a fixed number. Infinity, if you think that you have arrived to the infinity, is because you haven't arrived. Infinity is a concept that you have not arrived, never arrived to the infinity. Okay, so if you say limit when 2 plus, is because you are approaching from the left, from the right, moving from the right to the left. If you say 2 negative, you are approaching from something that is 2 less than 2, negative, less than 2. 2 positive, you are approaching with numbers that are bigger than 2, like this one, bigger than 2. So you can do also, so as I said, the 3 ways are 1, graphic. The graphic show that you will never arrive to a fixed number. If you are approaching the 2 from the right, you will arrive to the infinity. It means infinity is not a number, you will not arrive to a fixed number. If you are approaching from the left, you are not approaching to any fixed number, the limit will go to minus infinity. So the graphic approach will say that they don't have any, that this function 3 divided by x minus 2 doesn't have any limits. The limit doesn't exist. The data, when you plug in numbers like this, x equals 2.00, or you approach from the left, x equal to 1.9999. Wow. Or x equal 1.999999. When you approach, you will see that the calculators, when you do 3 divided by 1.999 minus 2, it will go to a big number. Every time that you plug in, that you are next to x equal minus 2, every time that you are next to the point x equal 2, you are going farther and farther, you are going to the infinity. So the limit doesn't exist. Now let's go to discuss the existence of the limit when x tends to 3 of the function f of x. The function f of x is defined like this. The value of the function is 5. 1, 2, 3, 4, 5. So the value of the function is 5, like this, 5, all the time, forever is 5, but at x equals 3, the value of the function is 1, is here. So at x equals 3, this function have here is not the rectilinear line. So it takes the value of the function. Now, when I approach from the right, from the left, from 3 plus, from 3 plus means for number, what's the value that take the function? If I approach from the right of 3, here, like this, the value that take the function is 5. If I approach, is 5. If I approach, is 5. If I approach, 5. And if I approach from the left, from 3 minus, well, I approach from the 2, 5. If I approach, 5. If I approach, 5. If I approach very next to the 3, but just to the left, 2.999, what will be the value? 3. So what is the limit of when x tends to 3 of this function? Is 5. So exists? Yes. What's the limit? 5. Okay, I hope it is clear. What this problem say that is not important what is the value of the function at x equals 3. The important thing is how, when you approach to the 3, which value will approach the function? And in this case, the value will approach to 5, always to 5. Okay, I hope it is clear. Now, based on what we have done, I think you can choose any problems to try to do this problem. These are from your textbooks, are exactly the same, and you can do any problem. You can ask me how to do it if you have any doubts. And I'll see you in office hour to check the solution of this problem. Let's go to do this one. Now, let's go to do another problem from your textbook. It's a plan management. Sometimes the problem have too many words, but what he's asking if this is the cost function, the cost to produce X units, or the cost to produce a certain percentage of units. What will be the cost if the percentage is 80%? This is what it's asking. So what will be the cost if X is 80%? Well, you substitute X equals 0.8, which is 80%. And if you plug in C of 0.8, you will obtain the cost to produce X unit at a level of 80% of capacity. And it will be 8 multiplied by 0.8 squared minus 63.6 multiplied by 0.8 minus 320 divide by x squared, 0.8 squared, minus 68 times 0.8, minus 960. Now I should be sure that this expression is positive because the cost to operate should be something positive. And let me see here, is 0.8 squared, 68 times 0.8. This is negative and this is negative, so should refer to find the cost C of 80. Now should be C of 80%, 8, so X is the percent, should be 8 by 80 squared minus 636 by 80 minus 320 divide by 80 squared minus 68 by 80 minus 960. So you should use 80, the number 80, and this way you obtain the value of the value of the cost function when x is a particular value of units produced. We'll see more problems in the future about business problems. First, we need to understand the calculus that is involved. This problem is an easy problem.